Now, we have looked at arc length. We have looked at area of a sector. Now, let's look at linear and angular speed. Linear speed is given by the formula that I have. I'm debating on putting it off to the side of what I'm going to do. Anyway, I'll just put it down below. V is equal to S over T. All right? If I have this one, S in this instance here is my arc length. But if I'm talking about, so it's the same arc length. S is S is S. Let's go black. Nah, let's go red. It stands out more. Arc length. So this linear speed that we have is, I'm looking at the speed as I'm going around the edge of my circle. So around that edge, that's how we get that arc length. All right, I'm not talking about going in this straight line. I'm talking about around the edge of my circle. All right, that's where that's coming in. T is time, of course. Oops. And V in this instance is my linear speed. Because V is for velocity. That's where that V came from. All right, so that's where some of these variables are coming in and making an impact. All right. So so let me just make a quick connection to you. Side note here. Most of you probably know that distance is equal to rate times time, right? That's what we're looking at. So if I'm looking at my rate here, I'm going to divide both of these by T. And that's what we actually have. So distance is equal to rate times time. That's a common formula. My rate, my distance is my arc length divided by that same time. So that's where, that's a connection that you can make to come through this. All right. Okay. So this is moving around the outside of my circle. That's what we're talking about. Now, if I want to know how fast my angle is moving, so maybe we ought to make that note. Moving out around the outside of my circle. Circle. And if I have angular speed, then I'm talking about my angle, how fast my angle is moving here. And we're going to use omega. I'll keep it in blue. Omega, which kind of looks like a curly W there. That's that Greek letter omega. Theta divided by T. And again, guess what theta is in terms of? Radians. Okay. So omega is that angle. Because remember how I said at the beginning here of this section, a lot of times we talk about things in terms of angles in Greek letters. Well, no difference here. So omega is going to be my angular speed that we have. Oops. Of course, T is still time. And then this is my angle in terms of radians. All right? And this is going to be that angle speed that I'm talking about. Not moving around the outside, but how quickly is my angle, the speed of my angle, right, increasing. Okay. Or decreasing, depending on how it is that we're going. All right, so check this out now. Here is our last example. I'm going to suppose that point P is on a circle with a radius of 10 centimeters and a ray OP is rotating with an angular speed of pi over 18 radians per second. Okay, now let's tap the brakes for just a second and make some connections. All right, so I know all my different formulas. So we can make connections between all of our different formulas as we work through this. So I'm going to come over here and let's make just this little chart. If I have angular speed, my angular speed we know to be omega is equal to theta divided by time, where this is radians per unit of time is what we're talking about, right? So because theta is radians divided by time. We also know that linear speed here is S over T. That's our formula that we know. However, look at what's going on. We also know the formula for arc length. So if I'm not given my arc length, we can figure that out. Velocity can also equal radius times theta divided by t, right? Because that is my formula here for arc length. Now look at how nice this pulls out. What else do you think is theta divided by t? Omega. You can also represent your linear speed in terms of radius times omega. All right, so all different kinds of connections can be made. Depending on the information you're given, you can take all of these formulas and work them through. All right, so with that little tidbit of information, let's look at what we actually have to do with this info. The first thing that we're going to do is find the angle generated by P in 6 seconds. All right, I am given angular speed. I am given this radius information, and in this instance, I am given time. So if I want to find an angle and I'm given this angular speed and time, I want to find the angle given angular speed and time. So basically, you're just looking at your formulas and saying, what information do I have and what information do I need to come up with? So here, I'm going to use omega is equal to theta divided by time. Omega we've got pi over 18 is equal to theta we're trying to figure out, and my time here is 6 seconds. So we just do work. Multiply both sides by 6. And then I get 6 goes into that 3 times. I just can't help myself. So now I end up with, wait, where's my blue? Theta is equal to pi over 3 radians. Right? Just use the formula. What information do you need from the formula? What do you already have? And then you just plug it in. That's all you're trying to figure out. All right? So we wanted to find the angle. Was the first thing that we found. And that's my theta here. What if I want to find, let's start with a different color, the distance. S traveled by P along the circle in 6 seconds. Traveled by P along the circle in 6 seconds. So I want to find traveling around the circle. That's my arc length. All right. So now I'm going to use my arc length formula. Now look at the information that we have right now. Arc length is R times theta. I just figured out what theta was because I'm still doing this in 6 seconds. So I now know that my theta is going to be pi over 3. So all this information, arc length, will be the same radius of 10 times that pi over 3 because I figured that out in my previous example. Okay, so then S, in this instance, if I chug all of that out, then we end up with, just leave it in terms of pi, 10 pi over 3 centimeters. And it's in centimeters because it's that distance, it's that length. All right? Okay. A, B. Let's do one more. C, on this same info, is I want to find the linear speed. Of P in centimeters per second. The linear speed in centimeters per second. Now think about everything we have. Linear speed from the information that we're going from. We know that with linear speed, we already have, we have a radius and an angular speed. So you can definitely easily come up with your linear speed from the information that you're given. So I have my radius of 10, my angular speed of pi over 18. Chug all of that out. Simplify this a little bit. If I divide by 2 gives me a 5. Divided by 2 gives me a 9. And my linear speed now, where's red, is going to be 5 pi over 9 centimeters per second. All right, just plug it in. That's the more